So let's do some basic dimensioning for the gear pump, the model number 1. I will do dimensioning for the heights, the diameters, and the depth we have for the cavity inside, and this will help you a lot to put all the dimension on your engineering drawings. I'll try to take as much photo as possible and share it with you as well. So what I'm going to do for the measurement, I'm going to use the vernier, I'm going to use the ruler, and because some of the dimension here required to have a special measurement devices that I don't have at the moment. So for example, I will start first with dimensioning the width and the length of the gear pump here. This one won't work, so we go to the ruler. The maximum dimension we can have here is 165. If you can take a look to the shape, you can see that the maximum dimension is going to be from here to here. This shape is arc, so I will need to take the dimension of these 2 points as well, the distance between these 2 points, and this will actually again to give you a hint to know what will be the arc of this point. So the distance between these 2 points is going to be 150. Okay, so the length from this point to that point is 150. From this point to that point it's 161. Now the height of that part is 70 millimeters. 70 millimeters. Now you can know that the center is going to be in the middle. We have 150, 161, and the width is 170 70 millimeters, and you can make the first sketch. Now the distance of that part, we're looking at 70 millimeters. The width is going to be 120. I'm not writing down, I'm going to watch the video later. 120. Okay, and actually this will give you actually how you can calculate this part as well. Okay, now 70, 120, okay, and 161, 150. These are the dimensions we have for this part. Now let's take some extra dimensions, like for example the diameters here and the length of the straight part we have here. So the length of the straight part we have here is 22 millimeters. 22 millimeters. So the upper side, which is facing the outlet port, is 22 millimeters length. Now let's see the lower one. It's 28. 22 near the outlet port, 28 near the exit port, so the inlet outlet port, and this one for the inlet port is going to be 28. Now the diameter of these circles and the maximum distance between them. Now I can do that by using the vernier, checking from that side. Okay, and this will be my first dimension. Yep, and the dimension is 112 millimeters. 112 millimeter. Now check the distance between these 2 parts. Okay, we're looking at 54 millimeters. 54 millimeters. Now we're looking at the circle diameter. We're looking at, of course, should be 61 millimeters. Have the same diameter of the maximum diameter of the shaft. So the diameter here is going to be 61 with very close tolerances, which should be larger than 61. Let's say 61 plus 0.05 millimeters. So the diameter of the holes, I know these are going to be standard, but I can take these diameters for approximation. We're looking at M10, of course. For the dowels, it's 9.4 millimeters. Now let me check the dowel itself. 9.4 millimeters. It's 9.45 millimeters. Okay, 9.45 millimeters, and that's why actually it's going to be fitted press inside the hole. Now the depth here is 52 millimeters. What else? That's it. Actually, that's what I need for this side. We're looking for the diameters we have here. This diameter is going to be equal to, just remember this one is going to be traced later. We're looking at 45.3. 45.3. That's for the outlet port. For the inlet port, we're looking at 41.3. Now you can of course find the distance between the centers as the distance between the two ends here is going to be equal to 170 millimeters. 170 millimeters. And the maximum distance we have here is 149 millimeters. 149 millimeters from here to here. This width here is going to be 101 millimeters. What else I need to measure? Yeah, I'm going to check what will be the thickness of the offset we have here. We're looking at 12 millimeters. The offset we're going to have for this one is going to be 70 millimeters. Okay, I've just checked these thicknesses, and of course this will enable you to sketch the part as you want. Now we're going to other details, like for example the top part. Just give me 1 second to move the light sensor. Now we're looking at the top part. I expect that, of course, the main thing we need to check is going to be what will be the thickness of the pushes wall we are going to have here. Dimension of these parts should be exactly the same as the main body. I'm going to take the thicknesses we have for this one. I forgot to take the part we have here. So the total height in general for the main body is going to be 112, and we need to take these two levels. I will take them by approximation only. Okay, we're looking at 73 millimeters, the height of that level, and you can subtract to find the height of that part. Okay, so for this distance should be equal to that's if you want to sketch it, by the way. It's 35 millimeter. This distance is 35 millimeter. Now you can find the other dimensions like these two lines. Now for the main body, I expect that the internal diameter of the bushes is going to be exactly the diameter of the shaft, but I'm going to do the measurement for it because I would like to check what will be the thickness of the bushes we have here. So we're looking at 32 millimeters. This will be the internal diameter of the pushes, 32 millimeters, and the external diameter of the pushes, or the diameter of the pushing housing, is going to be 36 millimeters. That means that the thickness of the pushes we have here is 3 millimeter. Now, because we took the two diameters, we're looking at 31 and we're looking at 36. Sorry, that means that the difference in the diameter is going to be equal to 5 millimeters. That means that the thickness of the wall of the pushes is going to be 2.5 millimeters. Now, of course, because we know the diameters of the gear itself, so we can find the difference between the two centers. But anyway, we can keep doing the measurement. So distance between the outside, between this point and that point, is equal to 87, and the internal one is going to be equal to 15 millimeters. So from here to here is sorry, I forgot to mention. Anyway, the distance from here to here is 15. And the outside distance is 87. So we have 87, we have 15, and remember that the diameter of the outside side of the pushes is 36 millimeters, and you can find the center points of these two holes. Now the depth of the pushes, which is going to be the height of the pushes, the depth of the hole is going to be equal to 35 millimeters. The total depth, because we have some extra depth to be added, is going to be equal to 39. So the length of the bushes inside this hole is 35, but the total depth we have for here is going to be the 39. Okay, now the thickness of this part, $18 millimeters. Okay, thickness of the part at the top here, 17 millimeter. 17 millimeter. We have 18 millimeters. Okay, and thickness of the supporters is 15 millimeter. And also we are going to check the difference between these two heights, and actually this will be one trick to be done. The height between them is going to be equal to 56 millimeters. So you subtract 17 and you'll find the difference between these two levels. Remember that these things can be done more efficiently when you use the height gauge. The diameter of this part here, the distance of this part here is square shape and have 80 millimeters. So we have 80 by 80 millimeter for this part. The circle we have in the middle, the outer diameter for it is 61. The internal diameter for it is going to be equal to 54. So this circle here, 61 and 54 to the inside. Now, of course, the diameter of the lip seal need to be dimensioned, and this is going to be equal to 43 millimeters. I think it's 44, and then we're going to put this seal inside, and because I took the internal side of the seal instead of that. Some of the details here, like for example, we have this hole and this to lubricate the seal, and also we have, I think that's it, that's all the dimension we need to put for this part. We're going now to the shafts, and in this shaft I discovered something that actually is going to be very useful for you to discuss in your report. I'm going to change the different lengths and different diameters. Diameters are going to be with the vernier. Now the gear length is 45, and the diameters are we're looking at 31.8, 31.8. We're looking at 31.8. Okay, now the diameters of these two levels is 31.8. The diameter of the supply level is 22. Diameter of the gear part is 61. Okay, so we're looking at 61, 31.8, 22. These are the levels we have. For the length of this part, we said is going to be equal to 45 millimeters. Now for these sides, it's much wiser to measure them with the ruler. I know it's not going to be very height accurate, but anyway, it's going to do the job. So we're looking here at 37 millimeters for this side, and the other side is going to be equal to 44 millimeters. That's without the taper, by the way. We have a taper here. You can ignore it in your calculation part. The length of the supply part is 30. So we're looking at 44. This part is 30. And the total length in general is going to be equal to the 84. And this will give you what the length of the taper shape we have here. These are the dimensions we have. For the sorry, just check something. We said here is going to be 44, and the length here is going to be 36. Okay, so 44 and 36. The lengths are not going to be the same. I think the same thing will be happening here, and this will be one of the points we need to discuss for this pump. Yeah, so we're looking at 36, and we're looking at the 44 as well. Of course, this one is going to have the same dimension of the gear we have on the other side, which is 45 millimeters. Diameter is going to be exactly the same. Now, that's mean if I'm going to put the two shafts in the wrong position, you can see that the level of the gears are going to be different. It always should be the correct position. That's one of the things we are going to talk about in the design for the assembly for that part. Now, of course, we don't have to talk a lot about this part because we already have the dimension we have for the cavity. Maybe it's going to be a good idea actually to have the dimension here. We're looking at 38 millimeters, okay, for this distance, 38 millimeters. We have a small square here inside. I can do it with the vernier, but I can do it also with the ruler. But anyway, we're looking at 10 millimeter square in the middle. The diameter of this circle is going to be diameter of larger than the diameter of the shaft, and diameter of the shaft was actually 31.8, so we're looking at here 34 millimeters. So it's going to be 2 millimeters more than the diameter of the shafts. Okay, so this for the model number 1. We are going to go to the model number 2 dimensioning.